Welcome to the demo. This is a deep research agent I built from scratch in TypeScript using AWS Bedrock. It takes any natural language question and produces a comprehensive cited report fully autonomously. Now, let's run the agent on this question. So here, uh, we'll see that each line is a structured log with step number, tools fired, token spent, etc. So while that runs, I have a completed run of this exact question here, which I'll use to walk through the code. Now, the core is a budget-bounded while loop. Claude receives all 51 tools every turn and picks freely, no handrouting in the code. Tools are namespace across web, source, extract, data, etc. Now, let's go back to the log file. Here we see in step 2 that the model called agent delegate research tool 5 times in one run, which means that we started five subagents parallelly at 1530 milliseconds apart. Each subagent is a Cloud API call with isolated context. The research subagent gets tool namespaces like web, source, extract, etc. Verify subagent gets knowledge, session, etc. So, and all of these subagents return structured format of findings, sources, gaps into the parent's knowledge store. So the parallelism comes free, all tool calls in one turn already run concurrently. Now here, let's go back to the log file and observe at step 1 that the number of cache tokens is 4650. Now let's go to step 2. It's still the same. Let's go to later steps further in the run. Okay. Now step 4. This has cache tokens of 5714, which means the cache is growing every step. The entire conversation history is being served from cache and not recomputed. Only the new message each turn pays full price. Before each request, we walk backwards through the message array, find the second to last user message, and append a cache point. So what Bedrock does is caches everything up to that point. So we are using three cache points in total: static system prompt, and for tool definitions, and for the conversation prefix. All of these things they never change, and the findings and plan they live in conversation history as tool results, and they're not injected every turn. So the cache hit always hits. Now let's talk about a moment where I and the model had a divergence moment. The original design had no caching at all. It was just a messages array where the old tool results are pruned after a fixed window, and the findings are reinjected into the system prompt every time. Standard manual context management, that's what Claude built, that's what I went with. And at some point, I realized that we were sitting on a KV cache or prompt caching. We weren't using it all. So I wrote a plan uh, for the context refactoring and brought to the session. The model's response was great. Then we added cache points as static system prompts and tools, like I explained. So from then on, the 4600 tokens got cached every turn. But the findings list still mutated in the system prompt every turn, invalidating the cache key on every call, which meant that the tokens kept increasing exponentially throughout the steps. But the model wanted to preserve this manual management layer. So then I had to push the two approaches are fundamentally incompatible. So what I did was make the system prompt fully static, stop the pruning, keeping messages immutable. But that direction didn't come from the model. It came from staring at a billing trace that didn't make sense. Now, let's look at the final log line here. We see that the session has completed in 12 steps, 75k tokens, which is less than half of the budget we allocated, with 49 tool calls and the report stored here. Let's look at the report. This is the full report generated by our agent. It has flowcharts and all. Impressive. But running is not the same as being good. There's an eval harness just for this reason. We run smoke tests in the first, just to see if the main concepts are uh, matched or not. Then we use an LLM judge, scoring factual accuracy, scoring on the completeness, scoring on the source quality and the depth of analysis and coherence and synthesis. After that, we use a second judge, which scores the planning quality and whether the subagent delegation was used appropriately. So this run scored 4.8 out of 5 on delegation. So the delegation judge assesses that it's near optimal orchestration. So it's rated on 5 truly independent subtopics in parallel, which synthesized into a coherent report with precise technical detail. That's the eval working as intended and to check that the strategy was right. The code, the eval harness, and the engineering memo are all in the report. Thanks for checking out.